Hello, the acceleration of a particle is modeled by A as a function of t equals 2t plus 1. The position of the particle at t equals 0 is 3, and the velocity at t equals 0 is -2. So what does that mean? If the position of particle at time equals 0 is 3, we know position that's represented by s. We know that s of 0 equals 3. And the velocity at t equals 0 is -2. So the s prime velocity, or s prime of 0 equals -2. Remember that we present the position by s. The derivative of position is velocity s prime, and the acceleration is s double prime. So this a as a function of time is in fact my s double prime. So let me go to the next page. Once again, acceleration as a function of time is the same as saying that the derivative as a function of time, which is the second derivative of the position as a function of time. Okay, let me start by s double prime equals 2t plus 1. And if I take the antiderivative of both sides, on the left-hand side, I get s prime. On the right-hand side, here is my t, my 2. Add 1 to the power of t, so I have t to the second power, divide by 2 or multiply by 1/2. Plus, remember that you can think of this as 1 times t to the power of 0. So now I have t to the power of 1. And I'm not going to divide or multiply by 1 because it doesn't matter. It doesn't change anything, plus some constant c. Okay, let's clean this up. So now I have s prime. And let me just, to be more, maybe I should just have done this as s double prime of t to make it more clear. And so s prime of t now equals 1/2 times 2 is just 1 t squared plus t plus c. So remember, we had two initial conditions. We knew that s of 0 equals 3. That doesn't help me anything. But s prime of 0, which is the same as v of velocity at the time 0, equals -2. So I'm going to use this information and say that -2 equals 0 squared plus 0 plus c. That implies that c equals -2. So I can rewrite this, exchanging the c with -2. Let me go ahead and go to the next page. So I'm going to go ahead and rewrite this as s prime of t equals t squared plus t minus 2. Let's take the antiderivative one more time. On the left-hand side, now I get s of t equals, here is my t squared becomes t cubed divided by 3 or multiplied by 1/3. Then I have t squared times 1/2 minus 2 times t plus some constant. I'm going to call it d, so we don't think of this as a previous constant. All right, let's clean this up. So I get s as a function of time equals 1/3 t cubed plus 1/2 t squared minus 2t plus d. And now I'm going to use my other initial condition because I have s of 0 equals 3. So I can claim that 3 equals 1/3 0 cube plus 1/2 0 to the second minus 2 times 0 plus d. So I know that d equals 3. All right. So I'm going to write this as s as a function of time equals 1/3 t cubed plus 1/2 t to the second minus 2t plus 3. And so that's position as a function of time for this particular particle. Let's do one more. How about if we have, let's say that we have a particle that its acceleration is a, so another example. So a as a function of time, let's say it is 10 times sine of t plus 3 times cosine of t and let's say that we are given that s of 0 equals 0. So position of the particle at time 0 is 0. And s of 2 pi equals 12. All right. So I'm going to go ahead and first rewrite my original problem. I know that acceleration is my s double prime as a function of time equals 10 sine of t plus 3 cosine of t. Taking antiderivative of both sides, I get s prime of t equals, here's my 10. Ooh, here is my 10. Antiderivative of sine of t is minus cosine of t. So times minus cosine of t plus 3 times antiderivative of cosine is sine. So sine of t plus some constant c. So s double prime of t equals minus 10 cosine of t plus 3 sine of t plus some constant c. And if I wanted to check myself, if I take the derivative of this part, I should get this part back just to check my work. If I take the derivative, I will surely, derivative of cosine is minus sine times negative 10, so it gives me 10 sine of t. Derivative of cosine is, derivative of sine is cosine, so yep, and derivative of c is 0. So my antiderivative is correct. Okay, so let me go ahead and go to the next page and take the antiderivative one more time. Let me, from last page, we had s prime of t equals minus 10 cosine of t plus 3 sine of t plus c. And let's just take the antiderivative one more time. Both of my initial conditions are telling something about position. So I have s of 0 equals 0 and s of 2 pi equals 12. So I can't use any of these initial conditions yet. Taking the antiderivative of both sides, now I get s as a function of time equals minus 10 sine of t minus 3 cosine of t plus c times t plus some constant d. Okay, so now I want to use my initial conditions. what is this S of 0, 0? What can that tell me? So if I plug 0 equals minus 10 times sine of 0 minus 3 times cosine of 0 plus some constant times 0 plus d. So 0 equals, sine of 0 is 0, so I get 0. Cosine of 0 is 1. 1 times negative 3 is minus 3. And then I have c times 0 is 0 plus d. And so this implies that d equals 3. D equals 3. Also, I can use S of 2 pi equals 12. Let me go to the next page. So 12 equals minus 10 times sine of 2 pi minus 3 times cosine of 2 pi plus c times 2 pi plus 3. We found that d was 3. So now 12 equals sine of 2 pi is 0. So this becomes negative 10 times 0. That's a 0. Minus 3 times cosine of 2 pi is 1. And plus, then I have 2 pi times c and plus 3. So notice that here, this 3 and negative 3 cancel. So I have 12 equals 2 pi c, and that implies that c equals 12 divided by 2 pi, which is same as 6 over pi. Okay, so my final step, I can claim that position as a function of time equals minus 10 sine of t minus 3 cosine of t plus 6 over pi t, and the value of d was 3. Yeah, minus 10 times sine of t minus 3 cosine of t plus 6 over pi t plus 3. Okay, thanks.